Okay, and welcome back, everybody. Today we're going to look more at matrices and systems of equations. So, here's the process that we're going to undergo today. We're going to be given a system of equations and asked to solve it. Through matrix algebra, we're going to change that system of equations into a matrix equation, and thus an augmented matrix. We already saw how to do that in the last section. Through elementary row operations, we're going to take the augmented matrix and convert it to row echelon form. You don't know what that is, but that's fine. I'll define it later in the lesson. Once in row echelon form, we're going to use elementary row operations to make the augmented matrix into reduced row echelon form. Again, definition to come. And by a theorem, we're going to have the answer to the system. What theorem is it? Well, here you go. If matrices A and B are row equivalent, okay, we still don't have a definition for that yet, then their corresponding linear systems have the same solutions. So if we can say that A and B are row equivalent, then the solution to each of the systems of equations are the same. So two matrices A and B are row equivalent if one matrix can be transformed into another via any number of elementary row operations. And you're going to denote that A tilde B. Okay? And think of like similarity, A and B are similar. Well, I shouldn't say similar because that means something a little bit different. But A tilde B is how we denote row equivalent matrices. So, what is an elementary row operation? There you go. There are three types. Okay, the permutation, where you swap two rows of a matrix. Scalar multiplication, all entries in a row are multiplied by a non-zero scalar. And replacement, you can replace a row with the sum of that row plus or minus, because of scalar multiplication, a multiple of another row. So, here's what we're going to do. Okay, and this problem is going to take a while, so I apologize in advance. But we're going to go step by step on how this process works. We're going to take this system of equations, okay, 2x1 minus 3x2 plus 4x3 is negative 3, and so on. And we are going to conclude that this system of equations has the same has the same solution set as this system of equations. And obviously this system of equations is quite easy to solve. We know x1 is 2, x2 is 1, and x3 is negative 1. So through this process that I kind of outlined on the first page, okay, we're going to convert the system to a matrix equation, then to an augmented matrix, and through the elementary row operations, we'll put it in reduced row echelon form and make our conclusion. So here's how it works. Okay. First off, okay, I'm not going to bore you with the intermediate step here, but because we did that last section, you're going to take this system of equations and convert it into an augmented matrix. So obviously the coefficients in the first row are 2, negative 3, and 4. There's 2, negative 3, and 4. On the other side of the equal sign, we have a negative 3. So I'm using this dashed line right here to denote the other side of the equation. Coefficients here are 1, 4, and negative 3. 1, 4, and negative 3. On the other side is a 9. 1, 0, and 2. 1, 0, and 2, with the other side being a 0. Okay. So my first order of business, okay, and I'm not going to provide you with the motivation as to why yet, but I'm going to make my new row 1, so I'll call that row 1 prime, my old row 3, and I'm going to make my new row 3 my old row 1. So all I'm doing is flipping rows 1 and 3. Now, question immediately pops up, do you have to show all these steps? And the answer is yes. Okay. Up until the very first midterm, whenever you're doing elementary row operations, I'm going to have you show all these steps for full credit. Okay. Next, what's the next move? Okay, now we flip-flopped rows 1 and 3. So now I'm 1, 0, 2, 0, 1, 4, negative 3, 9, 2, negative 3, 4, and negative 3. Okay, so the next thing is I'm going to say my new row 3, so row 3 prime, is going to be twice row 2 minus twice row 2 minus row 3. Making sure that my sign is going to be right. Okay, so take 2 times row 2. What is that? Okay, I'm going to show my work here off on the side. That's 2, 8, negative 6, and 18. And row 3 is 2, minus 3, 4, and minus 3. I'm going to subtract the 2 together. In fact, I actually have it wrong. Sorry about that. I'm going to say this is row 3 minus 2 row 2. Okay, so you'll get the same answer either way. Well, you'll get a negative off from one another, but let's do it the way that I'm supposed to. So that's 2 minus 3, 4, and minus 6. Sorry. 2 minus 3, 4, and minus 3. Minus 2 row 2. All right. So let's get rid of that. That's my new. All right. So this is this is my old row 3. This is 2 times row 2, and my replacement says take the old row 3 and subtract off 2 row 2. So I need to subtract these equations. So I get 2 minus 2 is 0. Negative 3 minus 8 is negative 11. 4 minus the negative 6 happens to be 10. And negative 3 minus 18 is negative 21. So that replaces row 3. You get 0, negative 11, 10, and negative 21. Rows 1 and 2 stay the same. They don't change. So now, each of these matrices on the left-hand side are row equivalent. So this is row equivalent to this, which is row equivalent to that. Okay. Moving forward, I'm going to combine rows 2 and 3 now. Or sorry, rows 1 and 2 now. Okay. So how am I going to do that? Row 2, my new row 2. And let's make sure I get the order right this time. My new row 2 is going to be my old row 2 minus row 1. Oops, sorry, that's my old row 2. So there's no prime. My new row 2 is my old row 2 minus row 1. So my old row 2 is 1, 4, negative 3, and 9. My old row 1 is 1, 0, 2, 0, and I take the difference. So 1 minus 1 is 0, 4 minus 0 is 4, minus 3 minus 2 is minus 5, and 9 minus 0 is 9. All right. So that is my new row 2. So I replace it 0, 4, negative 5, and 9. All right. Keep this train a-moving. So, the next step here is I'm going to combine my row 2 and row 3 and replace row 3. So my new row 3, I'll just call it row 3 prime again, is going to be, and now I really am going to have to guess and see what happens here. Probably didn't do myself a service by showing all my work on the notes ahead of time. Let's say I'm going to multiply my old row 3 by 4. So 4 times my old row 3. And I'm going to add to that 11 times my old row 2. So where's 4 and 11 coming from? Okay, well, I'm multiplying row 3 by 4 because the least common multiple of 11 and 4 is 44. So if I multiply row 3 by 4, I get 0, negative 44, multiplying by 4 now, so that's 40. And I'm multiplying by 4 now, so that's negative 84. And I'm multiplying row 2 by 11, so that's 0, 44, 11, so that's negative 55. And 9 times 11 is 99. Okay, and I'm going to add that together. What do I get? I get 0 and 0 and negative 15, and negative 84 plus 99 is positive 15. So that is my new row 3, and there it is, 0, 0, negative 15, and 15. My last step, until I take a break, or second to last step before I take a break, is to take my, let my new row 3 be my old row 3 divided by negative 15. So that means I'll take row 3, 0, 0, negative 15, and 15, divide it by negative 15, and what do I get? Well, I get 0, 0, 1, negative 1. Again, what I'm doing is I'm dividing these pieces by 15, negative 15. So, once I'm here, I'll take my old row 2 and replace it with a new row 2, and the new row 2 is going to be a scalar multiple. I'm going to divide everything here by 4. So it's going to be my old row 2 divided by 4. So I divide this by 4, I divide this by 4, I divide this by 4. And I get 0, 1, negative 5 fourths, and positive 9 fourths. Okay, and this augmented matrix is in row echelon form. So how do you define what row echelon form is? Let's see if I can. A matrix is in row echelon form if any rows with all zeros are at the bottom of the matrix. Okay, well, I don't have a row with all zeros. I have a row with some zeros, but not all zeros. So I don't have to worry about condition number 1. The first non-zero element in any row, which is called the leading entry, is a 1. So if I start at the top and work my way down, the first non-zero element right here is a number 1. That's good. The first non-zero in row 2 is a 1. The first non-zero in 3 is a row 1. That's why we had to do these scaling operations here at the end. So that satisfies condition number 2. And the leading entry of any row is to the right of the leading entry in any above row. So this is any above row. So the leading entry here, the leading entry of any row is to the right of the leading entry in any row above. All right, so you can't compare row 1 to any row above it because there's no row above row 1. So let's look at row 2. The leading entry is in the second column, and that is to the right of the leading entry above it in row 3. The leading entry is in column 3, and it's to the right of the leading entry in column 2 and in column 1. So condition number 3 is met. So what do row echelon form matrices look like? They look like this. Okay, the first non-zero element. Okay, well, first there's a couple rows with all zeros in them. Place them at the bottom. Okay, the first non-zero element in any of the rows is 1, and the leading entry of row 2 is to the right of any row above it. There you go. Here, all the zeros at the bottom. Okay, all the leading entries are 1s, and the leading entry of row 3 is to the left of the leading entry of row 2 and row 1. Okay, what are these stars representing? These stars are representing any number you wish. Okay, so really the things that we're looking at are 1s and 0s as leading entries and rows full of zeros. But you can take any of these stars and make them 2s, 3s, 4s, 5s, 1s, or 0s. Doesn't matter to me. Okay, last one, complicated, but really not. There are no rows with all zeros in them. Okay. The leading entry in every row is a 1. Yeah, there's a 0 before it, but leading entry is a non-zero term. Okay, so there's the leading entry of row 1, leading entry of row 2, row 3, row 4, row 5. So they're all 1s. And the leading entry is to the right of any of the rows above it. So right here, this is to the right of row 4, 3, 2, and 1. So that works. This is to the right of rows 3, 2, and 1. This is to the right of rows 2 and 1. And this is the right of row 1. Okay, so these are all examples of matrices that are in row echelon form. And how did we get there? By elementary row operations. Okay. Before we jump back into our problem, a couple more definitions. The position of a leading entry in row echelon form of a matrix is known as a pivot position. Okay, so looking at this matrix here, this is a pivot, this is a pivot, this is a pivot, this is a pivot, and this is a pivot. Okay, pivots are always 1s. Okay, the column that contains a pivot position is a pivot column. Okay, so this is a pivot column, but this isn't. This is a pivot column, this is a pivot column, this isn't, this isn't, this is, this is, this isn't, this isn't. Okay, I'm just looking for the columns where you have a leading entry of a 1. The rank of a matrix is the number of pivots in any row echelon form of a matrix. So how many pivots do I have in this? 1, 2, 3, 4, 5. I have 5 pivots. So the rank of that matrix is 5. A couple notes here. There's never going to be more than 1 pivot in any row. There's never going to be more than 1 pivot in any column. So any row or column must have 1 and only 1 pivot. Can it have fewer? Yes, but it can't have more than 1. So, strategy. Okay, when placing something into row echelon form, first thing you want to do is locate a pivot in the upper left-hand corner by swapping rows if necessary. Step 2, use elementary row operations to create zeros below that pivot. Okay. Once you've done that, move 1 row down and 1 column to the right and repeat the process. So, if we kind of wanted to rewind, take you back into the notes. Okay. The first thing I did was I moved row 3 up to the top. Okay. And then I combined rows 2 and 3. So that there was a 0 below and that was leading row 3. Okay, and then I combined rows 1 and 2. Where'd it go? Oh, here we go. I combined rows 1 and 2 so that row 2 started with a 0. And therefore, this became my first pivot. Row 1 started with a 1, that was the leading entry, and there were zeros everywhere below it. So once I've done that, move 1 row down, 1 column over, and do this process over again. Okay, so the next thing I did is I made there be a 0 down here in row 3, okay, by combining rows 2 and 3. So combine these two guys, put a 0 down there. Once I had a 0 down there, I made this a 1 by scaling, dividing by -15. And once I've done that, I divided row 2 by 4 so that I had a 1 leading the second row. All right. Well, hopefully my fingers didn't get away in front of the camera. I'm not actually looking at the camera as I videotape. But I just wanted to show that I followed that process when putting the initial matrix in row echelon form. Okay, back to our example. The next step is to place our matrix in reduced row echelon form. So before I define what that is, let me show you how you do it. Now I'm going to take and replace row 2. So row 2 is going to be equal to, let's say 5/4 row 3, 5/4 row 3 plus my old row 2. So 5/4 row 3, okay, that's 0 times 5/4, 0 times 5/4, 1 times 5/4, so 0, 0, 5/4, and that's -5/4. And I'm going to add to it row 2, which is 0, 1, -5/4, 9/4. So adding these guys together, I get 0, 1. 5/4 and -5/4 is 0. -5/4 and 9/4 is 4/4, but 4/4 is 1. So that's my new row 2, 0, 1, 0, 1. Next step, let's combine rows 1 and 2. Okay, my new row 1 prime, is going to be equal to, let's see, row 1 minus 2 times, oh, I probably have it the other way. Let's see. Row 1, I'm going to start it this way, hopefully I have the difference right, is going to be my old row 1 minus 2 times row 3. Okay, so as I do it, I'm going to take row 1, which is 1, 0, 2, 0. I'm going to take 2 times row 3, so that's 0, 0, 2, -2. And I'm going to subtract the 2 from one another. What do I get? 1 minus 0 is 1, 0 minus 0 is 0, 2 minus 2 is 0, 0 minus the -2 is 2. Okay, so that replaces my old row 1 with 1, 0, 0, 2, and this matrix is in reduced row echelon form. So therefore, what can you conclude? Okay, you can conclude that this matrix, augmented matrix, which referred to this system of equations, is similar to, or is row equivalent to this matrix right here through elementary row operations, which means these two systems, okay, the one that's over here that's more complicated, that pertains to this augmented matrix, and the one that here that's very simple, that pertains to this augmented matrix, have the same solution set. Well, I'll tell you, solving this system is a lot easier than solving this system, okay? But you know that their solutions are the same because of the theorem that I stated at the beginning of class. So, take you back to where we started. Okay. We start with the system, you can't see this. We start with the system of equations, that's right here. We convert it to a matrix equation and then to an augmented matrix, that's right here. From our augmented matrix, through elementary row operations, we put it in row echelon form and then reduced row echelon form. So that's right here. This reduced row echelon form corresponds to this system of equations. This system of equations has a solution that's easily seen, and by the theorem stated, is the same solution set as this system of equations. Therefore, x1 is 2, x2 is 1, x3 is -1 is the solution to this system of equations. And that's how the process works. So how about a definition for reduced row echelon form? Okay, so a matrix is in reduced row echelon form if the matrix is in row echelon form. So it's got to be in row echelon form first. And any leading one has zeros not only above it, but below it, but above it. Okay, so reduced row echelon forms looking for zeros below the leading entry. Reduced row requires zeros below and above. So this is a leading one, this is a leading one. These aren't leading ones because there's 0 rows. Okay, so you look in this row for this leading one, there's zeros below it, there's nothing above it, so that doesn't matter. Here's this leading one, there's zeros below it and above it. So this matrix is in reduced row echelon form. Same here, zeros below and above, zeros below and above. This is not, there's no leading one in this column, okay? So our first pivot column is right here, there's zeros below it. Nothing in here, there's not a leading one. Okay, the next leading one is this column, zeros below it, zeros above it. Next leading column, leading one is here, zeros below it, zeros above it. Same for here and here. All right, so long-winded example done. Okay, let's practice one on our own. So let's reduce this matrix to row echelon form. Okay, and once we are in row echelon form, we'll put it in reduced row echelon form. So here's what I'm going to do. This is how I would expect you to solve a problem like this. First is I'm going to state the operation I'm going to do. So I'm going to say the new row 1 prime is going to be, well, I need a 1 that's in the top left-hand corner, or at least I'm going to try to put a 1 in the top left-hand corner. How do I do that? Well, I notice here that each of these entries are a multiple of 3. So I'm going to say let row 1 prime equal what? Let's say row 1/3 times the old row 3. And what am I going to do with the old row 3? Or the old row 1? I'm going to make the old row 1 into the new row 3. Sorry about that. So in other words, I'm going to swap rows 1 and 3 and then divide row 3 by 1/3, or by 3, multiplied by 1/3. Okay, so you please try not to do many steps all at once, okay? But if you're gonna do a swap and a scale, that's very easy to follow, okay? If you're gonna do something a little bit more complicated, please do it over the course of 2 steps. So let's see. What does this turn into? Taking the old row 3, dividing it by 3, and putting it in my new row 1. So it's 1, -3, 4, -3, 2, and 5. Row 2, nothing happens. 3, -7, 8, -5, 8, and 9. And my new row 3 is my old row 1. That's 0, 3, -6, 6, 4, and -5. Okay, now I have a 1 in the upper left-hand corner. I need zeros below it. So how do I get zeros below it? Okay, well, I need to get rid of this 3. How do I get rid of the 3? I'll say my new row 2 is going to be 3 times row 1 minus row 2. So I'm going to multiply this by 3 and subtract off row 2. So let's show my work over here. I get 3, negative 9, 12, negative 9, 6, and 15. Maybe I shouldn't have divided by 3. Oh well. And I'm going to subtract off row 2. So it's 3 minus 7, 8, minus 5, 8, and 9. What do I get? 3 minus 3 is 0. Here's something you got to be careful of. Okay, there's a lot of negatives going around. Let's make sure that we're careful with our addition and subtraction. Negative 9 minus negative 7 is negative 9 plus 7, which is negative 2. 12 minus 8 is 4. Negative 9 plus 5 is negative 4. 6 minus 8 is negative 2. 15 minus 9 is 6. Fair warning, if you make a silly negative mistake or a silly arithmetic mistake, you're going to get a wildly different answer than what you should. Okay? So be careful as you go through this. Okay, you will get better at it. Things will become much faster as you go. So that is going to be our new row 2. So 0, negative 2, 4, negative 4, negative 2, and 6. 0, 3, negative 6, 6, 4, and negative 5, and 1, negative 3, 4, negative 3, 2, and 5. All right. Fair warning. Another fair warning. I could very easily make a mistake doing this, in which case my answers would be wrong. Hopefully you pick it up as we go, but I think we're good so far. So now, column 1 is as it should be. Okay, there it starts with the 1, there's zeros below it. Okay, now I need to go over or down and over. Okay, and start with a 1 in row 2. Okay, so let's make row 2 prime equal to 1/2 the old row 2. So that's 0. Oh, it's going to be negative 1/2. I need to divide by negative. So 0, 1, negative 2, 2, 1, negative 3. I'm dividing the old row 2 by negative 2 so that I can make it start with a leading entry of a 1. 0, 3, negative 6, 6, 4, negative 5, 1, negative 3, 4, negative 3, 2, and 5. All right. So, this is my leading entry for row 2. Are there zeros below it? No, there's not. So I need to replace row 3. Row 3 is now going to be 3 times row 2 minus row 3. So 3 times row 2, 0, 3, negative 6, 6, 3, negative 9, and 0, 3, negative 6, 6, 4, negative 5. What does that end up being? We're going to subtract those together. 0, 0, negative 6 minus 0, 0. 3 minus 4 is negative 1. Negative 9 plus 5 is negative 4. So we get this to be 1, negative 3, 4, negative 3, 2, and 5. I apologize, this is starting to look ugly. Maybe this helps, who knows. 0, 1, negative 2, 2, 1, negative 3. And what's row 3? 0, 0, 0, 0, 4 zeros, negative 1, and negative 4. All right. So now, our second leading one is correct. I have it with 1 and zeros below it. So where's our third leading one? Well, the third row has its first non-zero entry is all the way over here to the right, and it's negative 1, not positive 1. So we need to make our new row 3 equal to the opposite of our old row 3. So you get 1, negative 3, 4, negative 3, 2, and 5. 0, 1, negative 2, 2, 1, and negative 3, 0, 0, 0, 0, 1, and 4. Okay, and now we are in row echelon form. That's what it looks like. So for reduced row echelon form, what we need to do is we need to ensure that not only are the zeros below the ones, which there are, but the zeros are above the leading ones, which they aren't. Okay, so how do we do that? Row. So looking at row 2, we need to make this element a 0. So what we're going to do is we're going to say our new row 2 is our old row 2 minus row 3. So our old row 2 is 0, 1, negative 2, 2, 1, and negative 3. Our row 3 is 0, 0, 0, 0, 1, and 4, and we're going to subtract these guys together. You get 0, 1, negative 2, 2, 0, which is what we want it to be. Negative 3 minus 4 is negative 7. So we get 0, 1, negative 2, 2, 0, negative 7, and 0, 0, 0, 0, 1, and 4. All right. On to new page in the notes. So, again, there's our pivot, there's our pivot, there's our pivot. Okay. There's 0 below each of our pivots, but there's not zeros above. So now I need to pick on row 1. Okay, so row 1 prime is going to be my old row 1 minus 2 times row 3. So I'm going to multiply row 3 by 2. That's going to make this a 2. That's going to make that an 8. And then when I subtract 2 minus 2, that's 0. So 1, negative 3, 4, negative 3, 2, and 5, 0, 0, 0, 0, 2, 8. Subtract these together. You get 1, negative 3, 4, negative 3, 0, and negative 3. And that's my new row 1. 1, negative 3, 4, negative 3, 0, negative 3, 0, 1, negative 2, 2, 0, negative 7, 0, 0, 0, 0, 1, and 4. So if you look at this leading one here, there's zeros below it. Actually, there isn't anything below it, but there's zeros above. Okay, that is ideal. When you look at this leading one, there's zeros below it, but there's not zeros above it. So we need to correct that. So we need to replace this negative 3 with a 0. How do we do that? Let's see. We need our new row 1 to be our old row 1 plus 3 times our old row 2. So if I multiply old row 2 by 3, that makes this a 3, and I add them together, I get that to be 0. So it'll look something like this. 0, was it 3 row 2? So it's 3, negative 6, 6, 0, and negative 21. I'm adding. So that's 1, 0, negative 2, 3, 0, negative 24. So my new row 1 is 1, 0, negative 2, 3, 0, negative 24. Row 2 didn't change. Row 3 didn't change. Let's find our pivots. Pivot, pivot, pivot. Okay, so there's zeros below this pivot, nothing above it, that's fine. there's zeros below this pivot and above it, and there's zeros above this pivot but nothing below it. Perfect. So this is the same matrix in reduced row echelon form. So not the most exciting stuff, okay, but that's how it works. And what we can say is that the original matrix is row equivalent to this matrix that's in reduced row echelon form. Okay, so that's what chapter or section 2.4 is all about. So have fun practicing this. Again, you're going to want to show your work, okay? That will go away after the first midterm, but get in the habit of doing it now because I will look for it when grading your first midterm. Have a great one.